Hi there, my name is Mark and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video details my results for December of 2025, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. Here is a picture of the Sense device that measures my power usage and solar energy generation. It is located inside my electrical panel and clamps sensors onto the wires. As you can see from the monthly summary statistics, a total of 488 kilowatt hours of electricity were generated by my solar system in December of 2025. The standard cloudiness of fall and winter has come. Here is a picture of our 16 kilowatt ground mount solar array. The solar array is directly south-facing in one of our pastures with no trees or other obstructions around it. We have 50 ZN shine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240-volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed, no time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using the Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. Here is a day-by-day chart showing the total number of kilowatt hours of solar production and house usage for December 2025. The highest solar production day was on December 30th, where 52 kilowatt hours were generated by the system. There were 8.5 hours of sunlight that day. There were 15 days of very heavy cloud cover, where total production was less than 10 kilowatt hours for the entire day. It was a very dark month, overall, but very typical for our area. Here is a graph of the solar generation and usage, sampled once per minute on the peak solar generation day of the month. It was below freezing for most of the day, but the sky was clear, so solar generation was quite good for this time of year. The usage spikes over 15 kilowatts were when the electric furnace turned on, with the other spikes for the electric water heater needs. About half of the total electricity used for the day of 78 kilowatt hours was used by the furnace. This graph shows the per-day net difference between the amount of energy sent to the grid minus the amount of energy received from the grid. Ideally, every data point would be above zero, meaning that generation met or exceeded the usage. There was only one day in the month that the net usage was positive, but that's okay and is expected. You can see that if I were to have batteries and wanted to be completely off-grid, I would need at least 90 kilowatt hours worth of storage, which would be astronomically expensive. This chart shows the low and high temperature on the farm for each day in December. High of 16 Celsius was definitely higher than usual for December. There were a number of days that went down below freezing overnight. The low for the month was the same as in November. Here's a yearly comparison of solar production, comparing by month, along with a cumulative total for the year. This year's total production, in red, was 19.34 megawatt hours. This is the highest ever since the system was installed. I'm super pleased with this total generation. Here's a yearly comparison of energy usage, by month of the year. A total of 18.59 megawatt hours of electricity was consumed for the year, as opposed to 19.34 megawatt hours of electricity generated. This means on a calendar basis, solar production was greater than usage by 749 kilowatt hours. That's really awesome and shows that the investment is worth it. Here's a graph showing the actual amount of money I paid to the power company for each month from 2022 through 2025. The $7.49 bill is for the standing charge to have a power meter, even if no net billable amount of electricity is used. We now have 21 months in a row of only the standing charge as our bill amount. This continues to show how solar power can work even in a relatively cloudy location like Western Washington State. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. I will put out a separate video showing more data from the entire year of 2025 of my solar generation system, so stay tuned.